Greetings, fellow nerds. Welcome to another thrilling episode of Between Two Nerds, where we talk with prominent guests about all aspects of the networking industry, from protocols old and new to industry trends and drivers to up-and-coming technologies and, as always, things you should know to further your career. Jeff T is in Australia at IETF this week, so my friend and Apstra teammate Adam Jarvis is filling in for him. Hi, Adam.
Hi, Jeff. Thank you for having me on. It's a pleasure to be here.
It's great. Great to have you on. We've actually wanted to take advantage of having you on as a guest host for quite a while, or possibly a guest. We may have you back as a guest sometime too.
Yeah, you never know in the future.
Yeah. So, what time is it there in London area?
6 o'clock in the evening.
Okay, so it's not too
definitely
late.
colder than Australia at the moment.
Yeah.
Jeff's got the better deal.
Yeah. So, since it's your first time on the show, do you want to just tell the audience a little bit? I should mention we've got an all Apstra show today. All our guests, and we'll talk about our two guests in just a moment. You'll see them pop up, but Adam, you want to just introduce yourself briefly?
Yeah, sure. Yeah. So I work in the Juniper Apstra team. I've been at Juniper for about 5 years, and then I transitioned into the Apstra team after the acquisition. And mostly because I'm super fortunate that I really like network automation, data centers, and in that weird Venn diagram, Apstra sits in the middle of that. So yeah, I've been working on the Apstra team. Yeah, doing that kind of thing. Cool.
So, yeah, as I mentioned, this is going to be an all Apstra show. It's, as all of you know, this started off as an all Apstra show when Jeff Tansura was also here at Apstra, and he went off to bigger and better things. And so we have been more multi-vendor. That's always a good word that we like to use, but today it's kind of an old home week. So, Adam, you want to introduce our two guests?
Yeah. So we got two other guests joining us from the product team, which is Adam Grochowski, and we've got Carl Baxter as well. So I'll let those guys introduce themselves. And
hi, guys. Welcome to the show.
Yeah,
Adam, you're muted there. Just an FYI.
Whoops.
There we go.
Thank you.
Yeah. So
I'm gonna make everybody read my lips the entire time.
That's right. Yeah. So we thought we would take this show. It's kind of a new feature in Apstra, which is Apstra Flow data. I forgot which our official name. I keep calling it Flow data. So that must be the right one. But Adam and Kyle are very involved in that, among other things, obviously. But it's a great example, I thought, since we have that feature and we've been talking about it so much, to just talk a bit about flow data itself generically, and then we want to use just this new feature in Apstra to show how much analysis you can do on your network, how many insights you can get into your network by leveraging flow data, which is something people have known and loved forever, but it's not always so easy to deal with. Kyle, I know you came with a few slides to sort of give us a start on this. Do you want to start by bringing in the slides?
Yeah, I'd love to. So let me pull up my content and get that up. And while I'm doing that, just a little introduction on myself. So my name is Kyle Baxter. I'm a product manager here at Juniper in the Apstra group. As we said, this is an all Apstra show. So I'm going to be talking a little bit about why is flow data important to you, and how you can use it, and the value you can get with providing this to your network. So let's get into it a little bit, and we're going to be using our new Apstra flow data solution as kind of the example that we can use through this discussion and talk. But as everybody that has managed a network or been an operator or been involved in it knows, that network operators are surrounded by problems. And I'm sure everybody that's been there has looked kind of like this guy, and it's frustrating when it's always blamed the network first. It's always the network's problem. And so what do network operators do to fix these problems? We call it things like mean time to resolution or mean time to innocence, because it's not always the network's fault. And so this is one of the capabilities that you can use to help in those kinds of scenarios. So when I talk to users and operators, usually we can divide up the kind of challenges into different categories. So the first one in the top left around control plane and configuration, this is things like BGP, managing, make sure you don't have config drift. What do you do when people go in and make changes via the CLI, out of band or out of normal management processes? How do you keep that in play? And so within Apstra, as an example, we have things like this that we can control and make sure that this doesn't happen and alert when it does. Another category is environmental. So these are, monitoring the environmentals of your hardware. So the CPU, the fan, the memory on your switches, the optics, the cables, all of that being able to monitor those capabilities. Now, the third one is all sorts of additional services. These are the customizations that you make, and usually you're looking at various show commands to see, how is that set up, how are they operating, those kinds of things. Now, the fourth one that we're going to focus on today is, what about what's going on in your applications? Because this is really the key in your data centers that you want and need to focus on, because applications is what the service you're providing. So it's great if your config is working as expected and the hardware is operating as expected, but if your applications aren't working, your data center is not operating as you want it to. So getting insights into what's going on in those applications is absolutely key, and looking into flow data is a really good way to be able to get that insights into what is going on. So,
and I'm sure just to jump in there, I'm sure that
please,
everybody in our audience knows that there are multiple protocols supported by, sometimes it depends on the vendor. Sometimes there's multiple protocols even with one vendor that generates flow data. Basically, a switch or a router will generate that, and
right.
So that piece of it has actually been around for a long time, and the being able to interpret it well is always a little bit problematic.
Oh, absolutely, Jeff. That's 100%. I mean, we'll look at some of the different protocols here in a second, and some of the ones that are still used today were invented in the 90s. So they're coming up on 30 plus years old of how long they've been around and still used. But absolutely, the key is, what do you do with that data? Because just having a mound and pile of data is great, but being able to make sense of that is really what's key. And what you're really trying to get and make out of that data is things that you see here. Why is service running slow? What applications are consuming your resources? Security is absolutely key these days in knowing who's accessing your services. Am I getting attacked? Are people accessing bad sites? What about knowing your capacity? Because everybody's trying to maximize their investments. How do you know if your links are properly utilized? Are they underutilized? Are they overutilized? I mean, how do you really know until you start looking at how your traffic is flowing? So absolutely, these insights that you can get from the flow data is really where you get the value. Just collecting a bunch of flow data is is nice, but you're just going to have some massive storage cost and not really get any value out of it. So turning that data into something you can visualize is the really value statement that you can bring to these kinds of capabilities. So I wanted to ask kind of the group, what have you seen on how do people keep an eye on their network? Because I've talked to a lot of operators, and you hear things like SolarWinds or third open source tools, or they're building something in house and people struggle with it. I'd love to get some feedback. Jeff, Adam, what have you guys seen in your experiences?
Yeah.
I can tell you, a few years ago I used to work in a NOC, and our tool for monitoring was a syslog screen, which just every syslog event went past us, and that was one of the main ways that we monitored the network. So anything on top of that would have been an incredible enhancement.
Yeah, and I think I've, like you said, there's been tools available out there, for a while. SolarWinds is probably the first tool that most people think of, or tools, a suite of tools, really, for monitoring flow data. But there's all kinds of open source tools too, and it seems like, and I don't really know why that is, but in my own experience, it seems like people have been using a lot of open source tools, maybe feeling like they can adapt it better to whatever the challenges are of their network, things like Nmap and the such.
Yeah, it always seems like an afterthought, this kind of ability afterwards. It's always after you've implemented the data center and you've gone through that 3 months of design review, and then it's up and running, and you go, what about all the things that are actually on this data center? How does it look? So yeah,
exactly. Being network architects, you feel like, we built this wonderful super highway. Here you go, application folks, and then, like you said, kind of as an afterthought, all of a sudden, what do you mean your application is running slow? It couldn't possibly be what we built. So then you start installing some cameras along the superhighway to monitor things. How's that for a really bad analogy?
Yeah, I've heard of also people just putting firewalls everywhere just to be able to monitor and see the traffic, and then they're just adding unnecessary equipment to their network.
Yeah, unnecessary equipment.
Yeah, and I think
unnecessary jitter and latency also.
Exactly.
I mean, I haven't been in a NOC for a while, but I think that from my experience, we were using NetSaint, now Nagios, right? But that's simple up down, right? That's not actually showing you the actual traffic that's flowing on your network, right? That's basic monitoring of network services.
Yeah, and some of these applications, they can give you some really pretty graphs. But kind of leading into what Adam is going to show here in a little bit is there's not necessarily a lot of flexibility in how you can query those graphs and how you can build filters that say, okay, I like these graphs because I can see these general trends going on in my network, but I want to know about this specific application, or going to what Kyle said, I want to know, it looks like I've got a DDoS attack going on, where is that coming from, and what are the details on that, and needing to be able to do that kind of querying on the information you have.
Exactly.
Yeah. And furthering on from that, I mean, microservices applications, distributed applications, right? The network is the interprocess communication now. So if you're troubleshooting slowness on your authentication, maybe you have a microservice that handles authentication, you have another that handles the drawing the first page once you've actually authenticated. Like, so how do I figure out if users are saying it takes me a long time to log in? Is it because the auth piece is slow? Is it because the drawing that first page is slow? Like, how do I figure out what's going on? The network is integral to cloud native applications. So having this kind of visibility will let lets people figure that out more quickly, and it kind of blends well into the sort of DevOps space.
I guess that's true. The more distributed an application becomes, the harder it is to know actually what's going on under the hood.
Yeah, that is true. That is true. Well, within Juniper in our Apstra solution, as Jeff alluded to in the beginning, we've launched a new feature that is out and available now called Apstra Flow data. And what it does is not just collect flow data from the various protocols.
Just to interrupt, we've lost our slides there.
Uh-oh, lost the slides. Let me try sharing again. Sorry about that. I'll go back to present and we'll try that again. So let's pull that back up. And
there they go.
All right. Sorry about that. I don't know what happened, but as I was saying, in our latest Apstra release, we have launched a new capability called Apstra Flow data, and it is more than just a collector that we'll see, because the real power is not just collecting the data, but doing something with it, as we've been talking about. But we can capture different kinds of protocols, and there is multiple options out there, from S-Flow, NetFlow, IPFix, and even IFA. And so what probably you're asking and wondering and think about, well, which protocol should I use? Because there's multiple choices out there. What's going to be best for my scenario? And it really depends on what hardware you have and what you're looking for. But I'll walk through a little bit on kind of a comparison of the different options and a little bit of the pros and cons of each of them, so that can give you some insights on which one should you be looking at. So starting with NetFlow, this was created by Cisco in the late 90s. So it is still proprietary to Cisco. It was developed and built on some of their larger routers to start with. And the idea was it would send a summary metadata kind of package after a network flow was finished. So this is something to keep in mind, is it's not necessarily real time, so it can be delayed and come after the packets there. So may not be as good for detecting real time, say, threat detection, but it still can be used for that kind of capabilities. It typically has a little bit more higher computational overhead than some of the others that we'll get to, but it does have its advantages, and obviously there's a lot of Cisco gear out in deployments, so it is still popular and widely used. Now, the next one, IPFix, is an evolution on NetFlow in a way. It was based on NetFlow v9, so you hear a lot of people in the industry I've heard it called NetFlow v10, but it is more standards-based, so it is on more than just Cisco hardware, but very similar to NetFlow, where it's summarizing a metadata of the actual packets being flown through the devices. Now, the next one, S-Flow, is another industry standard one. The S in S-Flow stands for sampling. So it is a sampled flow, but what the sampling provides is it can provide more detail, and it can do it in real time. So what you set up in basic configuration is what interfaces and what your sampling rate is. Most of the time you start out somewhere in the area of one packet for every 1,000 you sample, and then you have counters that can help know the total number and throughput. But that sample is able to minimize processor load, so it's good for higher speed networks that we're seeing more and more today, especially with the explosion of AI and things like getting NVIDIA GPUs where you're needing 800 gig networks. S-Flow is probably going to be much better for those kinds of networks to understand what's going on when there's just very high traffic going through and you want real-time information on that capability. So S-Flow is usually where we tell people to start. because it provides kind of the best of a lot of the capabilities and minimizes processing load, and it's available on pretty much any hardware out there, and it's even on not just on switches and routers, but it's on firewalls, and even VMware sends S-Flow packets on their virtualized network. So you can get S-Flow on pretty much anything out there. The last one I'll just quickly hit on is IFA, in-band flow analyzer. This one's a more specific implementation on Broadcom chips. While it does provide real-time data, it's very specific. So you have to have very specific hardware on it. So that sometimes limits the usefulness of it. So that's why usually we go to S-Flow as a starting point. So hopefully that helps get some insights on what protocols are out there, what some of the advantages of each of them.
And I should add that the collector itself is just sort of hardware of your choice, right? Hardware / software of your choice. That is not an Apstra thing, correct?
It is built into our component. So we provide in Apstra. I'll go back to kind of this as a visual. As part of the Apstra Flow data solution, we have a packaged container that in a virtual machine that combines both the collector and the enrichment and analyzation piece and the visuals.
Okay.
But we have multiple hypervisor options that you can use, from VMware to like Ubuntu for KVM or Microsoft Hyper-V. So you have KVM options that you can put it anywhere you want. But for the Apstra solution, we've bundled in the collector because a lot of the smarts that we have is part of that collection where we're enriching the data and adding value to it that we'll talk about.
Okay. And what if, okay, I want to collect S-Flow, but I also find some advantages to IFA. There's some information in there maybe, and I might be talking out of ignorance here, but say I want to collect both of those flows and be able to do analysis. Can I do that, or do I have to select one of those protocols?
Most hardware is going to make you select one or the other. And in your example, if you have if you want to use IFA, you want all devices in the path to be able to support IFA.
Yeah.
Because otherwise you're going to lose out on information, because it's taken the whole network path and flow into consideration. So it's not just one node, but it's kind of there's some terms they use, like things like terminator and originator, and I can't remember exactly the terms. But for things like IFA, you want specifically to have in your whole network. But if you have some of the others, you can mix within your network. So if you have some devices that you really want, you want IP fix, for example, and some you're okay with sampled, you want to use S-Flow, you can mix and match that way. The collector that we have as part of our Apstra Flow data solution can collect all sorts of protocols at the same and be able to overlay that information together.
Okay, so it can collect multiple different protocols at the same time. It's not, the collector is just set. Okay.
Yeah, exactly. And multi-vendor by nature, because a lot of these protocols are standards based, that it doesn't matter if it's S-Flow coming from a Cisco or Juniper or Arista or any other device out there. You can think of various firewalls and other devices potentially in the path. Even I think wireless access points can send S-Flow for some of the higher end ones that you can get the information from. So because it's following standards, the collector just sees the information that's being sent and doesn't care if it was sent by whatever vendor.
Cool.
So you're probably thinking, well, this is all interesting and great, but what do I do with all of this data. And as we kind of have talked about already, gathering all this data isn't where the value is. The value comes in once you do analytics, enrichment, and you begin to present in a consumable fashion the data. Similar to this stack of Legos that you see on the slides here, the pile of Legos isn't really very helpful if you want to ask any questions or understand what you have. You just know you have a pile of Legos. But once you sort them and arrange them, maybe enrich them with some additional information, and you can present them visually, that's where you truly begin to see some value in the data you have. And that's what we've done, is not just collect, SFlow or IPFix or NetFlow or whatever protocol, but be able to enrich that information and present that in a way that can solve problems and provide insights, so you can reduce that time to resolution, or reduce that time to innocence, to prove that no, it wasn't the network's issue this time, and you need to look somewhere else, and be able to assure your applications that you're hosting that data center are working as you expect.
And I like the illustration there. Especially the big pile of Legos at the very top. Because over the years, and I'm sure you guys have all seen this too. You occasionally encounter network operators that are dealing with this flood of data about their network, and their solution is to try to limit in some way that flood of data, which is not a healthy idea, because every data point in that little pile there is unimportant until it becomes important, and so you really want as much information as you can get about your network, and for those instances when all of a sudden that data point that maybe you've not paid attention to in the past all of a sudden becomes vital.
Exactly, because you might not know which piece of that pile of Legos is the one you care about.
Exactly.
Yeah. Kind of like my syslog, watching the syslog screens. So that's what that big pile of bricks looks like.
Yeah.
And you have no context. It doesn't really give you any insight. You're just watching, hoping. It looks good on a movie, but that's about it.
Yeah, it's like looking for the needle in the haystack. But once you arrange it and you sort it, and that visually presented one, that little gray stack, that small one, that's your needle. It's like you wouldn't have found it in that big pile. But once you present it visually, it's like, oh yeah, there you go. There's my needle in the haystack right there.
Yeah.
So enough of me rambling on kind of high-level thoughts. Let's actually see what these dashboards look like. So I'm going to give some examples and kind of preview it, and then we'll dive into an actual use case and see this live. So starting with the first dashboard, we have capabilities of adding all sorts of different dashboards. And for those that are dashboard savvy, you may recognize this is using OpenSearch, which OpenSearch is a open source version of the Elastic Stack. So if you've ever used any of that, you'll recognize this, and it provides a lot of capabilities and flexibility that we will see. But our first dashboard we're going to talk about is top end. So this is your top talkers. And so this allows you to see exactly who's using all that bandwidth. So in this example, you can see a 192.168.211 IP address is using 4 terabytes of data. Was that expected or not? And that's what this can help you see, and potentially even at the services level, so you can see what services are using what bandwidth and how many packets they're sending, as well as even at the application level. So that way you can truly get insights into who is consuming that bandwidth and where is it actually going. Now, core services, this is always critical to know, is things like DNS, DHCP, Radius and LDAP for authentication, and even NTP, are they operating as expected? It's maybe not the service you're hosting and providing, but if these aren't working, nothing in your network is likely going to work. So being able to see those insights on these core services to know, is the number of requests and responses matching? If not, then it shows you time periods of when they were not matched to be able to dig into results. And even when somebody was mentioned earlier, what happens if maybe authentication requests are taking too long or getting lost? How do you know? And so being able to see insights into what's going on in your radius and LDAP for authentication can really provide some key value into insights on what's going on in your network. Now, the next one, and we're going to actually get into a live use case on this one, but is threats. Obviously, security is important these days. And how do you know if you're getting a DDoS attack? Are you like Adam and sitting around watching syslog? Or do you have availability to see this? And that's what this dashboard can help provide by looking at all the flow data to understand, are you getting a DDoS flood? Are you getting a brute force attacks? Or potentially reconnaissance scans to poke for vulnerabilities? How do you know if that's happening? Well, this can help you get those insights, and we'll see Adam show some more on this here in just a second. Now, another really nice view, and Sankey diagrams always show nicely, but how is your network traversing? So we saw, the top talkers who's consuming the bandwidth. Well, how do you then know how it's traversing your network and what services those are going through? So this can allow you to see those kinds of views in nice diagrams, and you can even filter, and all these views are filterable. So you can look at exactly what you want and in specific time intervals you want to be able to dive into. Where is your traffic going? This can be very key in understanding this information to know, is your traffic going where it's supposed to? Maybe people are accessing sites and you want to know where are they accessing it from. You can be able to get this information and be able to have this presented to you so you see, is your services accessing what it should be or not, and you can then have that insights. Now, another one I'm talking about earlier when I was talking about how do you know if your links are properly being utilized? Well, you can filter on all your different interfaces and see the throughput, if there's spikes in traffic. How do you then see those trends and be able to predict when maybe the next one's coming? This can provide some great insights on that. And then the last one I'll show before we get into an actual demo here, which will be the exciting part, is traffic details on how are your services segmented. So you can see things in here like how much is running IPv4 versus v6, what layer 4 protocols are being used in my network, or what VLANs are being traversed and used. So you can get these kinds of insights from the flow data that we can gather and see. So enough of slides. Let's transition and actually see something, so hopefully perk some interest, and see an actual use case and get to experience that. So I'll pass the baton to Adam and let him jump in, introduce himself, and actually get to a use case.
Thanks, Kyle. All right. So while I'm sharing my screen, I will, I guess, introduce myself. So Adam Grochowski, thanks, Adam Jarvis, for not butchering my name. And but I have been at Juniper for quite a while. I've been in a number of different roles, and now I am a colleague of Adam's on the Apstra product specialist team. So we work on all sort of as adjuncts to the product line management team, and work on aspects of Apstra and now Apstra Flow. So to Kyle's point, everything that we see rendered here, this is using the OpenSearch dashboards, right? Pulling information from OpenSearch, which is being deposited there from our flow collector, and the flow collector can collect, be sent SFlow, IPFix, NetFlow, IFA, and it itself doesn't, it has a bunch of different ports that you can send that traffic to. It itself doesn't care which port you send it to, because the flow collector is actually interpreting the traffic type and figuring out which bucket it fits into. And then it's also doing some enrichment along the way, right? So things like DNS names, which unfortunately I don't have DNS turned on here, but it would be enriched by the flow collector, that the geolocation, a few other things, and you can also add metadata to addresses, stuff of that nature. So I think first, unless, huh?
Oh, sorry. When you say enriched, does that mean so the SFlow data, for example, that comes from the switch doesn't have any? It just has the IP addresses. It doesn't have any intelligent information, I guess, or human readable information. And the
I mean, well, let's take, why don't we take a look at a flow record? I think that's actually probably a good thing to look at. So this is probably very small, so let me zoom in a little bit. So this is this screen here, right, shows you all the individual flows that you are collecting. You can actually click into them and get further information. So this is there is quite a bit of information. It is human readable, but certain things are being added along the way as it's coming through. So as a for instance, this interface information, this is actually being added by the flow collector, which is going out to the switch and saying, hey, what is index 521 from your perspective? And the switch is saying, oh, it's GE002, right? So we're adding that information to make it more human readable in the dashboard. Similarly, like if I had turned on DNS, we might be able to see what the individual IP addresses, host names were. Make sense?
Mm-hmm.
Yeah, it does make sense. Yeah.
Okay. So but this is all the information that you can see, and this is in fact a SFlow, right? So the other thing is I've got different kinds of flow data in this environment. It is a demo environment, so some of it is played not 2 months from now, as much as I always wanted to travel into the future. Can't do it with this. So we can collect a bunch of different kinds of data as we keep hammering on, but this particular box, if it would refresh properly, has some NetFlow, some SFlow, etc., because I've got a sample of data from a packet capture that was played back into it. But should we trigger a threat? Would that be a fun thing to do?
That's always a fun thing to do.
Yeah, if you can,
let's do that. Let's ramp this back to I don't know, let's say 15 minutes. Oops, I can type, I promise. So last 15 minutes, we'll hit our threat screen, and one of my favorite tools is HPing3. Use it for all kinds of stuff, but in this case, we'll use it to simulate a brute force attack. So I guess what I should say is I have a virtual environment that's running the flow collector, the OpenSearch dashboards, and in fact, Apstra itself. Really dead simple environment, 2 virtual machines, a couple of leaf switches and a spine. So what we can do is pretend like we're attacking one of our VMs from one of our other VMs. So we'll do that. All right, we'll do we'll take a look at brute force. So what this is doing is it's going to send 15,000 SYN only SSH connections to the SSH port, right? So once we kick that off, and give this a second and refresh and refresh and refresh, we should see this number start to climb, right? So Apstra Flow is telling us that, hey, something is going on here. I'm seeing a ton of connections between these boxes on SSH. And the cool part is this is all about how you render this information, right? It is very OpenSearch itself. OpenSearch dashboards are very customizable. Everything here is customizable. So to Kyle's point about core services, if you're not providing DNS services and DHCP, if you want to look at something else, you could add something to that. Just by modifying queries, right? So in this case, and I won't go super far into this unless you guys want me to, but in this case, we are doing we're making some assumptions about the nature of a brute force attack, and the assumption is that when you make a connection to try your password guess, it's going to be either a new connection each time, or a new connection, let's say every 3 until you're kicked out, right? So what happens then when every time you make a new connection, you get a new source port? So in the case of what we're looking for in this mountain of Legos is a count of changing source ports, right? And then destination ports of various things that you would log into, like SSH and Telnet, etc. So that's how the dashboards are built out of the box. We ship with the ones that Kyle has showed, but it gives you the ability that if you care about something beyond just SSH, brute force, or SSH, or LDAP, or VNC, or whatever else I showed in the filter there, you can add that and take a look at what's trying to attack your network. Yeah. So did that make sense to Adam and Jeff?
Yes.
Adam and Jeff.
Yeah, it did. Yeah.
Okay. So the to Kyle's point about figuring out what's consuming bandwidth on your network, right? You're doing capacity planning. You're trying to figure out why a certain link is running really hot. You can either kind of walk backwards or forwards between either looking at what's traversing an interface, or indeed so let's walk it back and see what's going across that interface by taking a look at the interface tab. Or you could take a look at, let's say, top services, right? So what's consuming most of the bandwidth on my network? Well, in this case, because we can travel in time, it's the 90s again, and there's a lot of IRC traffic going on here. So 63 gigs of IRC traffic. Well, what the heck, and where is that happening? So in all of these dashboards, you have the ability to create your own filters, and we make it easy. You can just literally click that plus sign. The cool part about that is now I have this traffic, this filter that says, hey, I want to look for IRC traffic, port 667, and it persists. So now I can hop over to my interfaces tab and say, all right, well, where am I seeing that traffic, right? So I've got the switches that I've showed you. Each one is exporting S-flow traffic, and I can take a look at them and actually see which interfaces that traffic is appearing on, right? And then I can walk back and figure out which maybe I have a machine that's infected with something that's actually using IRC for command and control, right? Maybe I have a botnet problem on my network. Now, in this case, it's just GE000 and 001 because I did that, right? I used HPing to send a ton of, even though it's coming from different IP addresses, right? So if we look at the flows, right? And again, this filter is persistent. We can see a relatively absurd number of source IP addresses sending this IRC traffic, right? And that's because I've used my buddy HPing 3 again to flood from one VM to another using a random source. So, but in any case, because I can keep these filters that I've added, right? I can kind of track down what's going on in various ways across the visualization options. Hopefully, try to figure out what's going on. So, what else should we look at? Somebody say something.
I guess one thing, you said you can customize dashboards. So
we can customize dashboards. Yep.
Can you create other dashboards as well, or are you limited to the ones that you see here?
You can, yeah. So you can you can create new dashboards. You know, you can and then add them, right? So every one of these little panes is editable, right? So these are just links to the individual. Whoops, that's not going to work, but because I've left the editing context, but they're just links to the various different dashboard elements, right?
Okay, so you could create one for like a different team, for example, or you start building them out.
Yeah.
Yeah.
Yeah, so you can create one. So like an example that we had from somebody at Juniper was they wanted to actually look at which VNIs were being heavily utilized, right? So he created a dashboard element that basically what he did was, because he liked having this flow information easy to look at, you know, on the top, and then on the bottom he added VNI information, so you could see which VNI's traffic was traversing as it went across the spines.
Oh, okay.
You know, there's so much talk now, including, you know, with Juniper about AI and networking. Are there AI elements in all of this, as far as what, you know, the processing of just raw data, as we were talking about earlier, into something very interpretable and very queryable? Are we using any AI elements in that?
It's a great question, Jeff, because you can kind of see where this could help you get to understand what trends are happening, to be able to see and predict what could be next. And that is absolutely something we are looking at. It's not in this version and release, but that is, you know, a natural next step and something we want to be able to use. You know, both, you know, being able to, you know, have LLMs that can, you know, query and use this as, you know, data where you can ask it, you know, human kinds of questions, but also to be able to feed into AI and ML models to predict when something might happen. Because if you look at some of the trends, you could say, you know, example core services, if you you know, always have, you know, a certain problem at certain times, it could start to predict that and be able to use that as trends. The same thing with some of the top end, looking at you know, your top consumers. If there's always some big, you know, service that's going on at some point, or a spike like what was just shown in that graph, you can see, you know, if there's always going to be a spike at a certain time, start to be able to provide those kinds of predictions. So that is a natural next step that we want to get to. But we got to get the data first, and this is our first step to get the data in we really had a fantastic start to get the presentation layer in a really consumable, easy way that'll make it really easy to lay the foundation for adding additional AI capabilities on top. So great question, Jeff.
Okay.
Yeah. I think one of the other things that I wanted to touch on, I unfortunately in this environment don't have a way to set this up, but going back to the idea of having an application that spans the network, some microservices type application, since you have the ability to add metadata to IP addresses or subnets, you could really help out an applications team. One of the things that I really like about Apstra in general, but Flow fits in there as well, is that you have application teams, you have V virtual admin teams, et cetera. They don't usually have access to what's going on in the network, right? They don't have the expertise. They don't have the access very often. So, between Apstra and Flow, you could give them visibility into what's happening on the network that they're consuming. And you could make it really easy for them. So if you knew that there was, again, going back to my example, if you had a microservices application that has, an authentication service, it has let's say it's a shopping site, so it's an authentication, it's credit card processing, it's displaying the different items, it's the click the purchase button, right? Let's say those are all different services. You could add metadata for the subnets or IPs that each service is on, and then give the application team a dashboard like this that they can then see. Oh well, we're having trouble with auth. We're having trouble with rendering, product images, and so on and so forth. And you can give them, understandable names, and you could give them further information, even maybe perhaps, including location within the, data center, right? If you wanted to add like hypervisor information or whatnot, if things were relatively static. So I think giving teams that wouldn't normally, that would basically call and say, hey, the application's broken, the ability to actually look and see, well, why is it broken, is a real strength.
And you touched on it in your presentation, but you have the capability in here, right, of in different ways of looking at long-term trends, right, across this data. So, for capacity planning, things like that, how, what's the rate at which, bandwidth utilization or interface utilization or any of those things is growing, and what applications are putting those demands out there, so that I can start doing capacity planning based on just the long-term view of what's happening in my network. I guess the easier way to have said that is using this data to baseline my network.
Yeah, I think that's an important point and strength, right? And it's not only necessarily figuring out what the tipping point is for ordering new hardware, as part of a capacity planning exercise, but it also could be rebalancing, right? But perhaps certain interfaces are running hot. You are mainly running virtual machines or containers. Maybe you don't have a capacity problem, but maybe you have a balancing problem. You need to move things around the data center to take better use of your very expensive your very expensive data center assets, right?
Yeah.
And how long can you keep data for? Is there like a limit on the amount of data you can store, or how the duration?
It's configurable. We have default settings for 7 days, just to prevent you from eaten through storage. but you can make it longer if you so choose, and you want to pay for additional hard drive space. You can absolutely, keep it as long as you want, or maybe more likely is take either all the data or some of the data and move it to potentially long-term storage locations where you can then re-access it later.
Okay,
that kind of goes into what I was asking too. That makes sense. Is you obviously don't want to spend the money to implement, something that can store 3 years worth of data. But there may be, going to trends. Can I, look at specific trends and then save just that so that I can then, within the data that I have, I can update it on a normal basis the trends in my network. Is that possible?
That's something we're looking at, and how we would likely be applying some of those AI predictions on those trends.
Cool.
Is using certain points of time, kind of snapshots in a way, to be able to say, yeah, this is what was happening at this point in various points in time, to be able to keep those long term without having to keep all the data and potentially terabytes or more of flow data around just to go back and look at it, but be able to use that intelligently and smartly.
Yeah. This was I really appreciate this is an enlightening demo, and an enlightening introduction, and I hope what our audience members are really taking away from that is the value you can get around flow data if you have the right analytics, I'm glad this came up at the end. Just the potential for AI in this, of really developing insights into what's going on in your network in ways that you might not think of querying it. And Adam, any last thoughts?
No, I don't think so. I think that was great. I mean, not an area that I'm particularly expert at, so it was interesting to see what you can do and how much information you can pull together and put some insights together, which I think is important.
Yeah.
So raw data is great, but insights are useful. So.
Absolutely. Yeah. What you do with the data is 100% where the value comes from.
Yeah. And I feel like that our expertise ticked up just a little bit here.
Yes.
Hopefully with the audience it also did. So Kyle and Adam, thank you so much for joining us today. I personally think this has been a very, very interesting and very educational show, and I think our audience will see it also. So we'll be back in 2 weeks. I think Tansura will be back from Australia by then. Maybe he'll will have added a little Aussie accent on top of his Georgian accent, and we'll be back with, in fact, our topic 2 weeks from now is on time variant routing with Mark Blanchet. Just so you guys, everybody knows. So the question is, how do you, as we start putting settlements somewhere like on Mars, or spacecraft a lot further out than just the moon, how do you use IP? How do you adopt IP? Because TCP, those distances and those times, you start having timeout problems. And how do you adapt to that? And people are working on it, including Mark Blanchet and Vince Cerf and some others. And so we're going to have Mark on to talk about some of those problems and what they're currently doing to encounter to counter that. So anyway, see all of you back in 2 weeks. And Adam and Kyle, thank you so much for joining us today. And we'll be talking offline very soon.
It was a pleasure. Thank you for having us.
All right.
Thank you, Jeff.
Thanks
Thank you
very
all.
much.
Thanks, everybody.
Thank you.
See you soon. Bye.